Well, that was fun. We're taking notes. We're taking notes on ions. So get your notebook ready, your pencil ready, and let's do some chemistry. Okay, now that you're ready, we can go ahead and start with a few definitions. First definition for the day is we're going to add to our definition of atom. Okay, so an atom is the smallest particle with no charge. What does no charge mean? That's what we're going to explore today, is talking about charge. What it means is that the number of the protons inside of an atom will equal the number of electrons that are in the electron cloud. This is going to be our definition of atom today. It's what we want to think about. Okay, not to be confused with isotope. Isotope is an atom of the same element but different number of the neutrons. Okay, but what we're going to put our focus on today is this one right here. It's called an ion. Hey, pay attention. I've got my eye on you. Okay, what we're going to call this is a charged particle. Um, and it becomes a charged particle when there's a difference in the number of protons and electrons. So an atom has an equal number of protons and electrons, but an ion has a difference in the protons and electrons. So if the number of protons and is greater than the number of electrons, then this means it's a positive charge. Plus means positive. And you might have guessed if the number of protons is less than the number of electrons, that means it's a negative charge. So we know that an atom's identity, an element's identity, is from the number of protons it has. That's the atomic number. So what happens is that atoms change to ions by gaining or losing electrons. Okay? An element's amount of protons will always stay the same for that element, but that doesn't mean the amount of electrons can change. So the amount of electrons can change. And when the amount of electrons changes, it becomes an ion. And there's some rules for how the electrons are gained and lost. So we got out our trusty periodic table, and we're going to look at this far right column. This far right column. Okay, those elements are called the noble gases. They're called the noble gases. NOB. The reason why they're called the noble gases is because they're unreactive. So let me tell you the quick story. So here's the lands, and imagine like mid-century England in the dark ages when they had like castles and stuff. This was a hard time in the world, especially for the people that lived outside of the castles, like these people. Okay, nobody cared about these people. Everyone only cared about the king and the queen who are up here. That's the, okay, that's the crown. This is the king and the queen living their wonderful royal life with their crowns. And these are the peasant people. Nobody cared about them. Well, if there were any wars that came, or if there was hard weather, and the peasant people couldn't escape the war, or they couldn't or they couldn't grow food because the weather was so cold, they would run to the castle and they would say, "Hey, please help us!" And what do you think the king and the queen did? They did nothing. They were unreactive. They didn't care. So noble gases are unreactive. They're called noble gases because they were named after the nobility. They are named after the kings and queens who are unreactive to the cries of the people. It's kind of a sad story, to be honest. Okay, so what does unreactive mean? It means that they don't chemically react easily or at all with the other elements. It means that they're stable. It means that they're stable. Um, yeah, it means that they're stable. What does stable mean? Imagine them like imagine these elements like all the other elements are like chemically combining and they're trying to hang out like they're friends. They're chemically combining, forming compounds and molecules. But these elements over here, they're that one friend that's like, no, I'm good, and they just want to hang out by themselves. They don't like to combine and make chemical compounds and molecules with the other elements. They like to stay by themselves. They're that one person who's too cool to hang out with anybody. That's the noble gases. Well, that kind of has an effect on all the other elements. All of the other elements want to have the same ratio of protons, neutrons, and electrons as the noble gases. They want to have a similar ratio. It's a special ratio of being stable. So what all the other elements have to do is that they have to either gain or lose their electrons in order to have this feature of stability and become more unreactive. Because all the other elements on the periodic table are highly reactive and they're highly unstable, some more than others. But when they do react, they're reacting in a way where they're gaining or losing electrons so that they can have this a similar electron configuration as the noble gases. The noble gases are the elements to be. All the other elements want to be like the noble gases. So let's start with an example. Let's analyze the fluorine atom and the fluoride ion. So we got, you're writing this down, fluorine atom versus fluoride ion. Okay, so fluorine atom, we know that is a particle that has no charge. So if we look at fluorine right here on the periodic table, it's number 9. So that means it has 9 protons. And since it is an atom with no charge, it must have 9 electrons to give us no charge. Remember, the number of protons equals the number of electrons with an atom. The fluoride ion um, still has 9 protons. That doesn't change because it's still fluoride. So that gives it the identity of fluoride. But fluoride ion is going to have 10 electrons. What happened to fluoride ion is that it gained one more electron to be just like the noble gas that it's closest to, neon. So fluoride ion gained one more electron. It went from 9 to 10 electrons, and now it has an overall charge of -1. Okay, so this is a trend that you'll see on the periodic table, and we'll do a few more examples. So next example, we'll talk about chlorine atom and chloride ion. That's fluorine and Chloride. Chlorine's the atom and chloride is the ion. So if we look at chlorine, it's right here on the periodic table, number 17, right here that I'm circling. So we know that chlorine has 17 protons. 17 protons. Well, chloride also has 17 protons. That doesn't change. Remember, what's changing is the number of electrons so that the ion can be stable like the noble gases. So what does chlorine want to do? What chlorine atom will do is it will gain one electron to have the same amount of electrons as the closest noble gas, argon. So what that looks like is like this. Chlorine atom with 17 electrons has a neutral charge because it's an atom. Chloride ion is going to have 18 electrons for a charge of -1. So you notice that both the fluoride ion and the chloride ion have a charge of -1, and it's because their position on the periodic table is just one away from the closest noble gas. It's just one away from the closest noble gas. You also may have learned that this suffix happens when there's a negative ion. So the suffix "ide" happens when there's a negative ion. Let's do another example. Okay, let's talk about oxygen atom and oxygen ion. Oxygen atom, if we find it on the periodic table, it's number 8 right here. So oxygen atom has 8 protons. Since it's an atom, we know it's electrically neutral. It has no charge, which means it has the same number of electrons for a 0 charge. How is that 0 and not 16? It's 8 positives plus 8 negatives. That equals 0. That means there's a no charge there. Okay, so oxide ion is going to be different than the other two examples because there's 8 protons, but this time there's 10 electrons. Now that's a difference of 2. So that means there's a -2 charge on the oxide ion. And if you look at oxygen on the periodic table, it's 2 away from the closest noble gas number, neon. So maybe you're starting to see a trend or a pattern here. But if we analyze sulfur and sulfur ion, you might be able to tell me that sulfide ion has a charge of -2, and it has 18. Sulfide ion will have 18 electrons, just like argon. Why don't you do this one right here as an example? Try and work this one out. Phosphide ion. Phosphide ion, P number 15 for phosphide ion. Go ahead and work that one out. Pause the video if you need. But the answer looks like this. Phosphide has 15 protons, but it has 18 electrons with a -3 charge because it's gaining 3 electrons to have the same number of electrons as the closest noble gas. So that's the trend that we're learning. I've got my eye on you. I've got my eye on you. Okay, so what if the ions are positive and not negative ions? Well, let's take a look at an example. Can you find sodium on the periodic table? Nah, you probably can't find sodium, can you? Nah. Well, there it is, sodium, Na is the symbol. And let's talk about sodium atom versus sodium ion. All right, so here's sodium atom versus sodium ion. Sodium atom and sodium ion both have 11 protons. There it is, number 11 on the periodic table. Okay, sodium atom, since it's a neutral particle, no charge, it must have the equal number of electrons. 11 positives plus 11 negatives is neutral. Well, sodium atom is number 11. Now we should ask ourselves, which one is the closest noble gas to sodium? Now you might go along the row and you might go all the way up here, but that would be incorrect because actually the closest noble gas to number 11 is number 10, not number 18. The closest noble gas to number 11 is number 10. So sodium ion has 10 electrons. And if you add those up, 11 positives plus 10 negatives, guess what? We have a +1 charge. And you need to write it like that with a +1 sign. Okay, if you're kind of getting the pattern, then you'll start to understand that every element in this first column right here has a +1 charge. And guess what? Every element in this second column has a +2 charge. So let's take beryllium for example. So Be for beryllium, and Be with a little +2 written at the top right here. That's how you show the ion symbol. Okay, so the Be atom has number 4 on the periodic table. So that means 4 protons and 4 electrons for no charge. That's a 0. The beryllium ion has 4 protons. But what's the closest noble gas? What is the closest noble gas element to beryllium? Remember, these are the noble gases over here highlighted. So it's not going to be neon this time. The closest noble gas to number 4 is number 2, helium. So beryllium will actually lose 2 electrons and only have 2 electrons in the end. And the charge is going to be a +2. Why? Because 4 positives plus 2 negatives is a +2. Okay, this one might be a tricky one here, but I want you to find the charge on an aluminium ion. That's aluminum for short. Just kidding. Okay, so if you find aluminum on the periodic table, you first note its number. There it is. I found it for you. It's number 13. It's not AI for artificial intelligence. It's AL for aluminum. So number 13. That means we know there's 13 protons. Well, aluminum is number 13, but it's kind of written over here on the right side of the periodic table. Well, still, which noble gas, we have to ask ourselves, which noble gas is closest to number 13? It's not number 18, it's actually number 10, because 13 is closer, the number 13 is closer to number 10 than it is to number 18. So we know that aluminum will lose the 13th, 12th, and 11th electron to have 10 electrons, like the closest noble gas to aluminum. So that means there's 10 electrons, and the charge on aluminum is going to be a +3 charge. Why? Because the protons are winning, they're winning by 3. The positive protons are winning, then there's 3 more than the negative electrons. Okay. Oh yeah, I forgot to note that the positive ions, their suffixes don't change. So we say aluminum ion as opposed to when we said earlier oxide. So because I say oxide and I see that the suffix changed from oxygen, that's how I know that oxide is a negative ion. Let's talk about writing the symbols down for these ions. So the symbol for aluminum is Al. And we learned in a previous video that the charge is written in the top right corner. If there's no charge written, that means it's an atom, it's not an ion. But since this is aluminum ion, we write a +3 right there in the top right corner. And that's how you show an ion symbol. Oxide. Oxide, we know from earlier, has a -2 charge. So we put a -2 right there. It doesn't matter if you put -2 or 2 negative or +3 or 3 positive. I've seen them written different ways in different chemistry books. They both mean the exact same thing. Okay, we're taking notes. Make sure you pause the video so you can write down everything you see here. We're going to be talking about most common ions. Now that you know what an ion is, you can talk about the most common ion, which is just an ion is an element that's most likely to form. It's the ion of an element that is most likely to form. Examples of most common ions that we've already talked about, oxide. We've talked about aluminum ion. We've talked about fluoride ion. We've talked about sodium ion. Sometimes they just write the plus without putting a little +1, or sometimes they write the minus without putting a -1 because the 1 is just shown by the plus right there. Okay, so these are all examples of most common ions. Examples of elements with no most common ion Well, I think I already told you. What are all the elements? All the elements are trying to gain and lose electrons to have the same number of electrons as the closest noble gases. So any of the noble gases, that's helium, neon, argon, krypton, etc. Okay, so now we can start talking about something called an ionic compound. An ionic compound, you might guess, is a compound that forms from ions. So we gave a definition of a compound earlier, and that's when elements combine together chemically to form compounds. Now we have a specific type of compound called an ionic compound, and that's when ions combine together to form an ionic compound. Okay, so the most common MCIs are written below. Let's review how we find the most common ions again. So if we look at the first example, Na, number 11, sodium. Remember that the most common ion looks like this. Sodium has, needs to lose one of its electrons to have the same number of electrons like the closest noble gas for a charge of +1. And that's what we write right there. Let's do two more examples. Let's do Mg. Everybody find Mg on the periodic table. There it is, number 12, Mg for magnesium. Now magnesium, if you notice, is in column 2, which means that it's going to it's going to lose the 12th and 11th electron so that it can have 10 electrons just like neon. So it's going to have a charge of +2. Why does it have a charge of +2? Because 12 positive protons plus 10 negative electrons gives a charge of +2. Okay, let's do this one way down here. Let's do Y. Let's find Y. Y is number, why are we doing this with Y? Okay, so Y is going to be number 39. Found it right here. 39 is not going to gain all of these electrons to be like number 54. 39 will just lose 30, the 39th, the 38th, and the 37th electron. So it loses 3 electrons to be like the closest noble gas, number 36, way over here, like krypton. So since it has 39 protons, but only 36 electrons, that means the Y has a +3 charge. Let's just do one negative ion example. I think I already gave you this example, so fluoride is a -1. Why don't you take the time to fill out the rest of those, and I'll give the answers in a moment. Pause the video. All right, if you haven't paused the video already, do so now, quick, because I'm about to give all the answers. Okay, pause the video if you need. Here they are. There's all the answers. And I hope what you're learning is that there's a pattern or a trend that you can follow on the periodic table of elements that helps you know what the charge is on each ion when an element forms an ion. Okay, that's called the trend on the periodic table. It says the colored PT, colored for periodic table. Here's the colored periodic table. Just ignore all of these little numbers inside of the boxes right now. But what we're looking at is that the red are metal atoms and the blue color are non-metal atoms. Why do we care about that? Well, the red metal atoms form positive ions, while the blue non-metal atoms form the negative ions. And I see how I wrote on the top of each column on this special periodic table. You'll get one of these sometime, and you'll be able to color in on your periodic table where the metals are and where the non-metals are, and where the charges are for each column. So these charges that are written -1 go for all of these elements in this column. That's the charge when they become an ion. Okay, so now we can build ionic compounds. And how do you build ionic compounds? One very simple rule is that you must balance the charges, the positives and the negatives. So how do we build an H2O molecule? Okay, so let's do an H2O molecule. H2O. Well, we know that there's how many hydrogens in the water molecule? There's 2. There's 2 hydrogens. Okay, 2 hydrogens. And how many oxygens are there? There's 1. There's 1 oxygen. Okay, so what are the charges on hydrogen? What are the charges on oxygen? Well, if you follow the rules, you'll know that hydrogen has a +1 charge. We could just write positive. And an oxide ion has a -2 charge. Well, these show the charge is balanced. So since the charge is balanced, we can have an ionic compound because the charge is balanced. What do I mean by the charge is balanced? Here's a balance right here. We have 2 hydrogens on the balance and 1 oxygen on the balance. Look at the charges. How many positive charges are there? There's 2 positive charges. So we could say 2, +2. And if you add that to the -2 charges, that gives us a balanced ionic compound. And so we can have the water molecule H2O. Let's do a few more examples so you understand what we're doing. Okay, so problem number 1 says to form the ionic compound with sodium and oxygen. Once again, you need the periodic table. So find sodium. Nah, you probably can't do it. Nah, probably can't do it. Oh, Mr. Edwards, that's sodium funny. I slapped my knee on that one. All right, so form the ionic compound with sodium and oxygen, MCIs, which stand for most common ions. So if you found sodium, you see it's in column 1. So we have a +1 charge for sodium, and it says to form the ionic compound with oxygen. We know it changes to oxide when it becomes an ion. So we have oxide with a -2. As a review, it's a -2 because it gains 2 electrons to have the same amount of electrons as neon. So 8 positives plus 10 negatives. That's 8 positives plus 10 negatives gives a -2 charge. Well, do we ask ourselves, do the charges balance? Well, no. There's 1 positive and then there's 2 negatives. The charges don't balance. So the rule is we have to balance the charges, and how we balance the charges is you can add another ion to balance the charges. So in this case, we have to add another sodium ion to balance the charges. Now we have balanced positive charges and negative charges. So the way we write the ionic compound is like this. Na, the positive ions go first with a little 2, showing that there's 2 of them in the compound and 1 oxygen. So this is the compound sodium oxide. And we know sodium oxide has 2 atoms of sodium with 1 atom of oxygen because the charges must balance in ionic compounds. This might be confusing, but if you keep practicing, you'll get better and better. Let's do number 2. Okay, number 2 says form the ionic compound with aluminum and chlorine. If you like the challenge, go ahead and pause the video and you'll get the answer in a moment. But I'm going to keep going with the work right now. So aluminum is symbol is Al, and chlorine symbol is Cl. Let's start with aluminum. Aluminum on the periodic table is number 13. Here it is. There's aluminum. Aluminum has a charge of +3 because its closest noble gas is neon, meaning that it has 13 protons, 10 electrons. If you add them together, that's a +3 charge. So the aluminum has a +3 charge, aluminum ion. Chloride ion, on the other hand, is number 17, which is right here. It has 17 protons, but when it becomes an ion, it will gain an electron. So it now has 18 electrons. So 17 positive protons plus 18 negative electrons gives a -1 charge for chlorine. Are the charges balanced in this ionic compound? No, they're not balanced because there's 3 positives and 1 negative. So it needs to be a fair fight. So it needs to be a fair fight. Right now, 1 aluminum can beat up on 1 chloride ion. So the chloride ions have to call their friends over. So here's another friend, chloride. Is it still a fair fight? No, it's not a fair fight. Still not a fair fight. Chloride has to call over another friend. Okay? So now there's 3 chloride ions against 1 aluminum ion, and that's a fair fight. And the way that you write the formula looks like this. Al for aluminum, and there's only 1 of them. And then you put Cl for chloride, and then you put a little 3 right there. And that's how you write the aluminum chloride ion. It's called aluminum chloride. Say it out loud. Aluminum chloride. Aluminum chloride. All right, people, you get to do number 3 and 4. Try them out. Try them on your own. See if you get the right answer. I'm not going to give you the answer. It's going to be a question. I lied to you. I'm going to give you the answers. All right, if you're still working on them, here are the answers. Pause it if you're still working on them, but here are the answers. 1, 2, 3. There's the answers right there. Okay, it was a tricky question, but yep, those are the answers. Okay, so now we can start filling out a chart with lots of information, with all the information that we've ever learned so far about atomic structure and isotopes and ions. And let's start filling out this chart. Number 1, 2, 3, 4, 5, 6, all the way down to 15. Okay, so the chart works like this. I'll do a few examples for you. Chart works like this. Each number is given, you're given enough information in that row to solve all of the other blanks in the problem. So for example, we're given the name in problem number 1, sodium, and we're given the mass number 23. When the number's written like this, it's the mass number. So sodium, if you look at the periodic table, has 11 protons because it's number 11 on the periodic table. So we would write 11 right there. Sodium with a mass number of 23 has how many neutrons? It has 12. How did I know that? Because I'm using this formula. The mass number, the atomic mass number, we should write atomic right there. The atomic mass number equals the number of protons plus the number of neutrons. So since we know that the mass number is 23 and the protons are 11, we just subtract 23 from 11, we get 12. God, I hope 12 is right. Okay, so sodium, it doesn't say sodium ion there, and it doesn't have a little positive charge or negative charge, so we know that it's electrically neutral. So the number of electrons equals the number of protons. It's an atom. So what's the charge? If the number of electrons equals the number of protons, that's 11 positives plus 11 negatives. That means the charge is 0. What's the atomic mass? It's given to us. It's given to us right there. It's 23. And what's the complete symbol? So how we show the complete symbol is we put Na for sodium, and we have the mass number on the top left. So that little 23 right there. And then we have the protons in the bottom left. And then we have the charge in the top right. We don't have to write 0 because there's no charge. You don't have to write a 0. Okay, let's do another example. Let me do the, let's do number 11. I'll do a number 11 for you. Okay, so in number 11, we're given all these blanks, but then we're given this symbol. So what are we given? We're given the symbol, we're given the mass number, and we're given the charge. So since we're given Se, let's find Se on the periodic table. There it is, number 34. Found it right over here, Se. Se is number 34. So what we got to do is write, for the number of protons, we're going to write 34. Okay. For the number of neutrons, I'm just going to calculate it up because I don't want to mess this up. For the number of neutrons, we have to take the mass number and subtract away the number of protons. That gives us the number of neutrons, and that's 45. Now, electrons are going to be interesting. It has a charge of -2. So let's look at selenium's position on the periodic table. Selenium is number 34. It has a -2 charge because guess what? It gained 2 electrons to be like the closest, to have the same amount of electrons as the closest noble gas, krypton. So that's a difference of 2 electrons. So we have a difference of 2 between the protons and the electrons. So that means the number of electrons is 36. That's 36. So what's the charge? 36 electrons and 34 protons. That's a -2 charge. That's also written for us right here in the problem. Okay, the atomic mass is 79 because it's written for us right there. And then the number of protons we need to write to complete the symbol, which is 34. Okay, and here's that says 34 right there. Here's the tricky part. You have to figure out the name of this ion. So you try and figure out the name real quick. All right, the name is, just had to look up the spelling, selenide. Did I spell that right? Maybe I did. Selenide, and then you can put the mass number, 79. So it's a lot of little things to remember. People think chemistry is super hard, but if you just memorize the patterns and if you know what the numbers mean, then chemistry starts to make sense and starts becoming really easy. You know what? I'm going to put the other equation up here that's helpful. The number of protons plus the number of neutrons, oh, excuse me, plus the number of electrons equals the charge. Okay? Now just keep in mind that protons are positive and electrons are negative. I thought that might help you out when you're about to fill out the rest of this table. But why don't I just do one more for you? Why don't we do number 14? That looks like it's the hardest one. It's down there at the bottom. Okay, so 14. 27 protons, 32 neutrons, 25 electrons. What's the charge? Well, there's a difference of 27 protons and 25 electrons, so protons are winning by 2. That's a positive 2 charge. Okay, what's the atomic mass? Well, the atomic mass is the number of protons plus the number of neutrons, so that's 27. 27 plus 32. That is 59 as the atomic mass. 59, that's 59. What is the symbol? Well, let's find number 27. Let's find number 27 on the periodic table. Bada bing, bada boom. There it is, number 27 right in the middle. Cobalt, CO is our symbol. CO is a symbol. Let me put that, make that O a little smaller. CO is a symbol. The mass number goes in the top left. The protons go in the bottom left. And the charge goes on the top right. Okay, and we're going to call this cobalt ion dash, the mass number is 59. Okay, what you're going to do is fill out the rest of this chart. Okay, if you need to write the chart, yeah, go ahead. You got to write the chart. Okay? Start writing stuff down, fill it out, and answer the questions.